All right, pre-calc students, day 1 of Unit 2, our unit name, Equations and Inequalities. First 3 days are going to be about equations, some complex ones, not easy ones, not Algebra 1, not Algebra 2, a little bit more challenging. And then the last couple days we're going to talk about inequalities, quadratic, absolute value, and rational. Probably used to Mr. D's voice because he did all the videos for Unit 1. I'm going to do all the videos for Unit 2, so a little new to some of you. My students, maybe not so much. Mr. D's students, get used to it. All right, so challenging linear or rational equations. So if I said solve this equation right here, if the x's were on top, it'd be Algebra 1. Since they're on the bottom, a little bit more challenging. The strategy that is easiest to use is multiply through by a denominator that gets rid by a value, that gets rid of all the denominators. In this case, nice, easy to start, would be x. 3 over x times x is 3. 7 over x times x is 7. And 8 times x is 8x. 10 equals 8x. X equals 8 tenths. 10 eighths, also known as 5/4 or 1.2. Pretty dang easy if you do it that way. Obviously, we'll make them a little bit more challenging where those denominators get to be a little harder. All right, why is 2 harder? Because there isn't one single value that will take care of all the bottoms. We need to get rid of the x, the 2x, and the 9. X will do well with the last one. 2x will actually do well with the last 2, but it won't take care of the 9. So what is the best value to multiply, the common denominator? 18x. If I do that, I'm going to do an extra step just because it's kind of new to us. The 9 and the 18x cancel, and I get 1 times 2x plus 1. The 2x and the 18x cancel, I get a 9 equals. The x and the 18 cancel, I get a 1 times 18. Lots of 1s. 2x plus 9 equals 18. Look what I did. Turned it into an Algebra 1 equation. Pretty dang simple. 2x equals 9, x equals 4.5. If you get equations that are decimals or fractions, that's normal, folks. Don't be intimidated by that in the least. All right, the last one, the last challenging linear equation or rational equation with a variable on the bottom. What is the magic bullet that's going to get rid of both a x minus 1 and a 6? And the answer is 6 x minus 1. 1 times anything is itself. I'm going to take a quick liberty this time, plus 5. The x minus 1's cancel, so I get a 6 there. 7. The 6's cancel, so I get an x minus 1 there. That's a whole lot more straight ahead. Nice linear. All x's on top. Let's do some distributing. 6x minus 6 plus 30 equals 7x minus 7. Subtract the 6 over. X minus 7 equals 30 minus 6 is 24. Add the x over. X equals 31. You can check it all you want. Again, getting rid of those denominators. Being confident in higher level intermediate algebra. Solving those types of equations. All right, moving on. Quadratics. X squared equations. We talked about another parent function from last unit. We did linear, now we're doing quadratic, x squared. The square root principle really means, in my opinion, treat it like linear. Meaning, old school, get the variable alone, do the same thing, opposite operation, same thing to both sides. How do I get x alone? Add 25. How do I get rid of a square? Square root. But don't forget, when you take that square root, it's got to be both the plus and the minus. 5 and negative 5. A lot of you thought, Mr. Ward, I might have factored it. We'll do factoring in a minute. I just want to show you another tool in your toolbox. Depending on the equation, I want you to use the quickest, best one. Don't be stuck to just one method. All right. A little bit challenging at first, but attack it by doing something like that. 9x squared equals 16. Makes it a whole lot easier. Again, square root principle, divide by 9. Well, if I got a decimal there, I think it's like, what is that, 1 7/9, 1.7 repeating, and then I had to take the square root. I can't do that. Instead, leave it as a fraction. Again, the plus and minus. Whoops, pardon me. 16's on top, 9's on the bottom. Why leave it like that? Because they're both perfect squares, plus or minus 4/3. 4/3 or negative 4/3. Nice, elegant, easy answer. All right, so that's the square root principle, treating it like a linear. What's the more straight ahead? That would be factoring. But we also have this tool in our toolbox called completing the square, and we're going to do that. Okay? Let's factor this first one. Purposely made it factorable. X and X. Factors of 9 that give us 10. 9 and 1. Negative there and positive outside means they're both negative. Solutions are 1 and 9. That's factoring. Completing the square. Let's go through those steps. Something you learned in A2, but we'll spend some time on it here. Group the x's. This one and this one. I say leave a hole. You can either move the 9 to the other side, or you can keep it on the same side. I'm going to move it to the other side for now. It would become a negative 9. What goes into this hole in the trinomial right here? Remember that good old rule of half it, square it. You may want to write that down here. Half it, square it. Half of 10, 5 squared, 25. Even if it's a negative, negative 5 squared is 25, positive 5 squared is 25. You can't just go around adding 25 to one side. You got to do it to the other. Why would we do that? Because this trinomial now factors to x minus 5 squared. 25 minus 9 is 16. Why is that better? Because now, if we use that square root principle idea from above, we're going to get x alone. Undo squaring by square rooting. Don't forget it's the plus and minus. I'm not going to write it this time because the square root of 16 is 4, and therefore negative 4. And if I add a 5 to 4, I get 9. If I add a 5 to negative 4, I get 1. Same answer either way. I don't want to do both of the, I don't want to do this next one both ways, so I'm just going to complete the square. Well, watch what happens. You'll tell me the same thing. X squared minus 2x equals 2x minus 5. Subtract over the 2x. Add over the 5. Mr. Ward, isn't that factorable? I don't know. Let's see. If that 5 is a plus and that 5 is a minus, what does that mean? They're both negative. Factors of 5 both negative. That would give me 5 plus 1 is 6, not 4. So it is not factorable. So that's not really an option. So we're going to have to complete the square. Good practice for us. Group, leave a hole. You know what? I'm going to change this one up because some of you might like to keep the 5 on the same side. That's fine. Half of 4 is 2, squared is 4. If I balance on the same side, over here on the other side, I did plus 25, left and right. Here I do plus 4 and minus 4, both on the same side. You should be comfortable with that. I don't want to confuse you. I just want to show you you're good. You guys are good at math. You got to be comfortable. X minus 4, x plus 4 is x minus 2 squared. Of course, it's a perfect square trinomial. Plus 5 and a minus 4 is a plus 1. That's our equation I'm going to solve. Subtract the 1. Oh, I lied last unit. I said we're never going to do imaginaries. We are going to do them real quickly here. Take the square root of negative 1 plus or minus I. Add the 2 over. 2 plus I. 2 minus I. 2 plus or minus I would be fine. Roots always come in pairs. In this case, they're both imaginary. Again, a couple tools in our toolbox. What do we got? We got the square root principle, we got factoring, we got completing the square. You should be comfortable at all methods. If you're not, that's what practice is all about. All right, let's keep rolling. Factor by grouping. I know a lot of us are intimidated by this leading coefficient other than 1. Here's a strategy. You can take 6 and 10. 6 times 10 is 60. Just bear with me. Factors of 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Man, there's a lot of them. Now, which pair am I going to decide on? The pair that gives me the middle term. And again, I want to stretch you. Your algebra skills, I want to stretch you. Make sure you can do things. Increase your math power. 6x squared plus 4x plus 15x plus 10 equals 0. I took the 19 and I broke it into two terms, 4x and 15x. Now, factor by grouping, we're going to group. First pair, second pair. And we're going to look for a GCF. What's in common to 6x squared and 4x squared? 2x. What's left over? 3x plus 2. Stop right there. See that binomial of 3x plus 2? That's got to show up in the second pair, or else we did it wrong. What's in common to 15x and 10? A 5. What's left? 3x plus 2. Beautiful. Just what we wanted. Now, that 3x plus 2 is in common there and there. First term, second term. If I pull that 3x plus 2 out, what I'm left with is the other binomial, 2x plus 5. If by all means you wanted to FOIL it to double check, good practice for you. 6x squared, 15x plus 4x, 19x plus 10, check. I'm not going to insult your intelligence by forcing you to tee it up. By all means, you can. 3x plus 2 equals 0. X equals negative 2/3. Just make sure you get it right. 2x plus 5 equals 0. X equals negative 5/2. Two fractional answers, factor by grouping. Let's practice one more. Let's see what we got. Clean it up. 7x squared minus an x squared is 6x squared. Plus 5x plus 2x is plus 7x. Plus 1 and another plus 1 is a plus 2. Now, in all honesty, I might consider not factor that by grouping because that 6 has a couple choices, but the 2 doesn't have any choices. It's got to be 2 and 1. But since we're practicing this method, factor by grouping, we're going to do it. Where did that 60 come from? 6 times 10. Where does the number come from here? 6 times 2, so we got a 12. Factors of 12, 1 and 12, 2 and 6, 3 and 4. The pair that gives me 7 is 3 and 4. 6x squared plus 3x plus 4x plus 2. I broke the linear middle term up into two terms, so I can now group. 6x squared plus 3x, 4x plus 2. What does 6x squared plus 3x share? A 3x. 2x plus 1. I hope I get a 2x plus 1. What do we got there in front? A 4x plus 2, so we could pull out a 2. And I'm left with 2x plus 1. Bingo. That binomial of 2x plus 1 is common, leaving me with the other binomial of 3x plus 2. And again, might not be the way you did it, but you should be comfortable with doing that. Tee it up if you want to. Subtract 1, divide by 2, negative 1/2. Be good at that. Subtract 2, divide by 3, negative 2/3. There's our two solutions, factor by grouping. All right. What happens if you can't do any of these methods? You have the quadratic formula. Now, in my rules, my world, the only way you can use the formula is if you derive it. I can't just hand it to you. We got to figure it out. So great place to stop. Part 2 of today, we'll derive the quadratic formula.